Jetsuit Race. The inaugural Jetsuit Race, held on February 28, 2024, in Dubai, marked a groundbreaking moment in aviation sports. Organized by Gravity Industries in collaboration with the Dubai Sports Council, the event featured 8 pilots navigating a 700-meter course over water near Dubai Marina, maneuvering through 12 inflatable gates while wearing jet suits powered by 1,500 horsepower engines. These jet suits, developed by Gravity Industries, utilize aviation fuel and can reach speeds up to 85 miles per hour, 136 kilometers per hour. Pilots control their flight by adjusting the direction of their arms, allowing for precise movements in three-dimensional space. Aerobatic racing drone. Aerobatic racing drones in 2025 epitomize the fusion of cutting-edge technology and high-speed competition, captivating audiences worldwide. These drones, designed for agility and velocity, are central to a rapidly expanding sport that blends virtual and physical racing experiences. The Drone Champions League, DCL, has revolutionized the sport with a new league format comprising 3 Premier Cups: the Falcon Cup, Eagle Cup, and Hawk Cup. Each cup features 14 matches, combining virtual and live races, culminating in finals that spotlight top-tier talent. The global racing drone market reflects this momentum, projected to grow from $493.59 million in 2024 to approximately $2.65 billion by 2034, with a CAGR of 18.31%. BlackBird. The BlackBird is a term historically associated with the Lockheed State Route 71 Blackbird, a high-speed reconnaissance aircraft developed in the 1960s. In recent years, the term has been used in various contexts, including references to successor projects like the State Route 72, a hypersonic unmanned aerial vehicle concept. As of 2025, there have been developments in hypersonic aircraft technology, with companies like Lockheed Martin and Boeing exploring concepts that could achieve speeds beyond Mach 5. These projects aim to enhance reconnaissance and strike capabilities, leveraging advancements in propulsion systems such as turbine-based combined cycle engines. While specific details about operational Blackbird successes remain limited due to the classified nature of such programs, the aerospace industry continues to push the boundaries of speed and performance in aircraft design. Orb Nomad. The Orb Nomad is an innovative electric vertical takeoff and landing (eVTOL) aircraft developed by Orb Aerospace, aiming to revolutionize personal aviation. Designed for accessibility, the Nomad is compact enough to fit in a 2-car garage yet boasts an impressive range of up to 1,000 nautical miles. A standout feature of the Nomad is its advanced fuel cell technology, developed in collaboration with partners. This fuel cell utilizes an organic agricultural byproduct, often discarded as waste in underdeveloped countries, resulting in an energy density 5 times greater than traditional lithium-ion batteries. This innovation not only enhances performance but also promotes environmental sustainability. To validate its capabilities, Orb Aerospace has partnered with the National All-Domain Warfighting Center for rigorous testing and integration with military operations. Flying Car TUSI. The TUSI flying car is an innovative electric vertical takeoff and landing (eVTOL) vehicle developed by Istanbul Gelisim University (IGU) in Turkey. Named after the 13th century Persian polymath Nasir al-Din al-Tuzi, this project embodies a fusion of historical inspiration and modern technological advancement. Initiated in 2018 by IGU's Technology Transfer Office, TUSI is designed as a single-passenger hybrid vehicle capable of both ground and aerial travel. It features a lightweight aluminum chassis and carbon fiber body, powered by a 75 kilowatts electric motor system. The vehicle employs an 8-rotor configuration, enabling vertical takeoff and landing capabilities. Pegasus E flying car. The Pegasus E is a groundbreaking hybrid flying car developed by Pegasus Aerospace Corp, designed to seamlessly transition between road and air travel. This vertical takeoff and landing (VTOL) vehicle combines the convenience of a car with the capabilities of an aircraft, eliminating the need for runways and fitting comfortably in a standard garage. Powered by a hybrid system, the Pegasus E uses unleaded gasoline for flight and electric power for road travel. It boasts a flight range of up to 450 kilometers, approximately 280 miles, and can fly for over 3 hours on a single tank. On the road, it offers a 70 kilometers, about 43 miles, range on battery power, reaching speeds up to 120 kilometers per hour, 75 miles. Pantuo Pantala H. The Pantuo Pantala Concept H is a cutting-edge electric vertical takeoff and landing (eVTOL) aircraft developed by Shanghai-based Pontto Aviation. Designed for urban air mobility, it aims to offer efficient, quiet, and sustainable transportation. Featuring a sleek design with tilting canard wings, the Concept H integrates 22 ducted electric fans, 4 in each front wing and 7 in each rear wing, powered by 22 electric motors. This configuration enables vertical takeoff and landing capabilities, transitioning smoothly to forward flight. The aircraft is projected to cruise at speeds up to 300 kilometers per hour, 186 miles per hour, with a range of 250 kilometers, 155 miles, accommodating up to 5 passengers. Vertical Aerospace VX4. The Vertical Aerospace VX4, also known as the Seraph, is a pivotal prototype in the evolution of electric vertical takeoff and landing (eVTOL) aircraft. Unveiled in January 2020, the VX4 was designed to test and validate technologies for future passenger models. This uncrewed multicopter features 12 electric motors and propellers, achieving a maximum speed of 80 kilometers per hour, 50 miles per hour. Its carbon fiber composite fuselage and customizable design allow for various landing gear configurations, including skids, wheels, or floats, facilitating operations in diverse environments. The VX4's development laid the groundwork for Vertical Aerospace's subsequent model, the VX4, a piloted, 4-passenger eVTOL aircraft with 0 operating emissions. Autoflight Prosperity I. The Autoflight Prosperity I is a pioneering electric vertical takeoff and landing (eVTOL) aircraft, marking significant advancements in urban air mobility. Designed by renowned automotive designer Frank Stephenson, known for his work with Ferrari and McLaren, the Prosperity I combines sleek aesthetics with sustainable materials, aiming to offer a premium passenger experience. In February 2024, the Prosperity I achieved a milestone by completing the world's first cross-sea and intercity eVTOL flight, covering a 50 kilometers route from Shenzhen to Zhuhai in China in just 20 minutes, a journey that typically takes 3 hours by car. This demonstration showcased the aircraft's capabilities in real-world conditions, highlighting its potential to revolutionize urban transportation. LEO Solo. The LEO Solo is an innovative single-seat electric vertical takeoff and landing (eVTOL) aircraft developed by LEO Flight Corporation, aiming to make personal air mobility accessible and exhilarating. Unveiled virtually at CES 2025, the Solo is fully funded and slated for production in late 2025. Designed to comply with FAA Part 103 ultralight regulations, the LEO Solo requires no pilot's license, making it an ideal choice for recreational pilots and aviation enthusiasts. Its compact dimensions, 16 feet in length, 12.5 feet in width, and 4 feet in height, combined with removable wing sections, allow for easy towing and storage. The aircraft is powered by a battery electric system driving 24 clustered electric jets, providing redundancy and safety without the use of propellers. JETRACER. The JETRACER is an innovative vertical takeoff and landing (VTOL) aircraft developed by French inventor Zapata, renowned for his flyboard air hoverboard. This single-seat flying machine is powered by 10 micro-turbojet engines, enabling it to reach speeds up to 250 km per hour, 155 miles per hour, and altitudes of 3,000 meters, approximately 9,800 feet. Constructed with a lightweight, modular carbon fiber chassis, the JETRACER boasts high maneuverability and stability, even in turbulent conditions. Its compact dimensions, approximately 2.04 by 2.04 by 1.53 meters, allow for operation from confined spaces such as rooftops, boats, or remote terrains. Safety is paramount in the JETRACER S design. The aircraft features redundant systems for propulsion, control, and power supply. Notably, it can continue flying safely even if 2 of its 10 Martin Jetpack. The Martin Jetpack was an innovative personal aircraft developed by the New Zealand-based Martin Aircraft Company. Initiated in the 1980s by Glenn Martin, the project aimed to create a practical vertical takeoff and landing (VTOL) vehicle. Unlike traditional jetpacks, it utilized a 200-horsepower V4 petrol engine powering 2 ducted fans, enabling lift and controlled flight. Designed for a single pilot, the jetpack featured a carbon fiber frame and landing gear, with the pilot standing within the structure and operating it via hand controls. It boasted a maximum speed of approximately 74 km per hour, 40 knots, a flight duration of about 30 minutes, and a service ceiling of 3,000 feet. Hoverbike S3. The Hoversurf Hoverbike S3 is a pioneering personal aerial vehicle that merges motorcycle dynamics with drone technology, offering a unique flying experience. Classified under the FAA's Part 103 as an ultralight aircraft, it requires no pilot license in the U.S., making it accessible to aviation enthusiasts. Constructed with a carbon fiber monocoque frame, the S3 achieves a lightweight design, weighing approximately 114 kilograms, 253 pounds. This structure not only enhances durability, but also allows the hoverbike to fit through standard doorways and operate from typical parking spaces. Powered by 4 33 kilowatts electric motors and a 12.3 kilowatt-hours Li-2 battery, the S3 can reach speeds up to 96 km per hour, 60 miles per hour, and altitudes of 5 meters, 16 feet. EHang 216. The EHang 216, a pioneering autonomous aerial vehicle (AAV), developed by EHang Holdings, has achieved several significant milestones in 2024 and early 2025, solidifying its position in the urban air mobility (UAM) sector. In January 2025, the EH216S model completed its inaugural demonstration flight over downtown Shanghai's Huangpu River, marking a pivotal step toward commercial air taxi services in the Yangtze River Delta region. This initiative is part of a broader strategy to integrate low-altitude economic activities, including aerial tourism and urban commuting, into China's transportation infrastructure. The EH216S has undergone rigorous testing, with over 40,000 flight trials across 17 countries, demonstrating its safety and reliability. Vertical Aerospace VX4. The Vertical Aerospace VX4, unveiled in 2018, was the company's first full-scale electric vertical takeoff and landing (eVTOL) prototype. This unmanned, remotely controlled aircraft featured a quadcopter design with 4 ducted electric fans, marking a significant step in Vertical Aerospace's mission to revolutionize urban air mobility. Building upon the VX1's foundational design, Vertical Aerospace has since developed the VX4, a more advanced eVTOL aircraft. The VX4 is designed to carry a pilot and 4 passengers, targeting a range of up to 100 miles at cruise speeds of approximately 150 miles per hour. Notably, the VX4 aims to be significantly quieter than traditional helicopters, enhancing its suitability for urban environments. EHang VT-30. The EHang VT-30 is a pioneering long-range, passenger-grade autonomous aerial vehicle, AAV, developed by EHang, a leader in urban air mobility, UAM, solutions. Designed for intercity transportation, the VT-30 complements EHang's EH216, which focuses on intracity travel. The VT-30 features a hybrid lift-and-cruise design, combining 8 propellers on both sides, fixed wings, and a rear-propelling propeller. This configuration allows for vertical takeoff and landing, eliminating the need for runways, and enables a flight range of up to 300 kilometers with a flight time of approximately 100 minutes. Safety is a paramount consideration in the VT-30's design.